All right, good afternoon. So, HPC. How do we go about making that a good cloud product and a reality in the federal space? That's really what we're going to talk about here. And normally I go through kind of a detailed history of how we got to the point where not only is cloud even an available government option, but what did it take to put all of the regulations, the NIST publications, standards and requirements around things like Henry's topic earlier, looking at FIPS 140 encryption, in addition to putting in place access controls like multi-factor, redundancies for backup, and things like that. It actually started about 2010, and there was a BPA awarded. Lots of problems, lots of issues, and it became very clear we needed a path, right? So FedRAMP is a path that was established. It's a federal risk assessment and management program put in place ultimately to allow commercial vendors to sell cloud products to the government. And essentially any cloud environment hosting federal data is required to go through this process. So I would definitely like to thank Henry again earlier for covering a lot of the pains that it takes to go through things like ISO, to go through other NIST certification programs, and even common criteria. So I'm just going to kind of move through these. The links are available. When you pull down the PDF of the slides, you can kind of look through these on your own. But as you see over time, I do want to pay special attention to February 2011, because this is when the cloud first policy was initiated, and it was stated in what's known as the Federal Cloud Computing Strategy. And ideally, what the government put forth was, look, if you're going to spend what's known as FSMA dollars towards anything IT related, whether it's software, hardware, networking, doesn't matter. If there's federal money being spent, then it needs to consider cloud first. And that's what they were educating and teaching 8 years ago, saying, hey, look to the cloud first, especially if it's going to be new. So, following that, there was an expectation of, okay, well, what are we going to consider a cloud? And I'll kind of jump in that in a minute. But kind of moving down to 2012, that's really when FedRAMP became operational. There was a 2-year period that allowed basically time for agencies, time for service providers to kind of get their ducks in a row, prepare for probably one of the most arduous audits they're going to go through. I think pins and needles was a good way to put it, but definitely it is a high bar to achieve. First year alone, there were only 8 companies that did it, mostly all infrastructures, right? Providing infrastructure as a service, and then you saw the next wave of platform as a service and software as a service companies starting to follow. Kind of moving forward there, 2014 is really when things became law. From that point on, all cloud systems that are going to host federal data had to be FedRAMPed. But in 2015, DoD jumped in and said, okay, well, we want to play too. However, we've got some additional requirements. And they developed what's known as FedRAMP Plus, created a cloud computing security readiness guide. They added additional controls, additional requirements, basically took the government standard and tweaked it just enough that it would satisfy DoD requirements. It is important to note that there are confidential and secret cloud elements out there. DoD refers to them as impact levels. In terms of how the cloud environments, should they be compromised, would impact the federal government, or the release or compromising of that data if a spillage did occur. Most recently, though, in October of 2018, we've made a shift from where we were 7 years ago in thinking cloud first, cloud first, cloud first. Well, now there's been a change, and it's referred to as the Cloud Smart policy, which is, okay, I know we told everybody, let's jump into the cloud as soon as possible, anywhere you can, convert everything to cloud. Well, now they're being educated a little bit more. Let's do it when it's smart. Let's do it when it's the right thing to do in cases where it should be. So the GSA For example, General Service Administration is leveraging the Google services or G Suite for their email, for their documents, which for them is great. For other agencies, it creates issues sometimes in terms of interagency, exchange of documents and things like that. So as far as it goes, Cloud Smart is what they're being taught now. So it's definitely come a long way in the last 7 years. Just kind of moving in here real quick. This is kind of important in terms of HPC and coming back around into how does HPC fit in this space. NIST basically has 5 definitions. On-demand self-service, broadband network access, resource pooling in those multi-tenant type environments, rapid elasticity, expanding and contracting, and then of course, measured service. They really, out of the gate, only defined three services, and what we saw following this was, backup as a service, artificial intelligence as a service, basically whatever someone was doing, slapped as a service on the end of the name, and let's go sell it to the government. Well, there is a level of responsibility that comes with this. And, starting from the left, looking at infrastructure, you'll notice the CSP is represented by red, agencies are blue. The cloud service providers have a very low amount of responsibility in terms of the number of security controls that they have to maintain. The rest is on the agencies. As we move up the stack into platform and then into software, you kind of see a line form, but there is no very clear straight line of delineation saying, here's what I've got, here's what you've got. In many cases, it is a shared responsibility where the CSP and the agency are working together to satisfy the security controls. A good example is access control. Governments connecting to the environments, right? So secure VPNs, multi-factor technologies such as smart cards, DoD Common Access Cards, HSPD 12. Well, the CSPs don't provide those, the agencies do. So that type of responsibility are things that have to be worked out. The next kind of example here is you could very well, across each one of these services, have multiple vendors working together to provide a single solution. And we call this stacking authorizations. So you could have a certified infrastructure who is then leveraging somebody else's platform, and then there is a SaaS provider sitting on top of those where all three are working together, leveraging their authorizations, then applying agency requirements on top of that to provide a single solution. This is actually the simplest example. So it can get, you can get creative with how you do this. So just kind of moving on the process and how the framework works, everything is actually based on FISMA, Federal Information Security Management Act. It is 17 years old. It's currently up on the Hill being worked right now to come out with a new version in 2020. But right now, this is what's law. This is what everything's based off of. So FedRAMP's not actually law. It is built on top of this. So in 2002, they basically said, if you're going to spend federal money on a system, we need it to be tested. We want to know what the security levels are. We want to know what the risk is. And we want to see a report on the security controls that have been selected by the various agencies. So they have over 900 security controls to choose from. It was very complicated, but it's also a snapshot. It's a once-in-a-day view of the security of a provider. So a few years later, roughly 2006-ish, Office Management and Budget, working with NIST and various federal agencies, developed what's known as a risk management framework, which, unlike FISMA, is a continuous monitoring environment, provides monthly reporting, penetration testing, annual reviews, what's known as a plan of action and milestones, or a document that can basically track and manage residual risk, right? To keep everyone informed, to say, okay, we know there's always gonna be risk in some shape or form, but what is that? How much is left? What is the categorization? It is a high risk, low, or moderate. So the risk management framework gave a mechanism to basically allow agencies to understand not only what is the risk of what they're purchasing and responsible for, but how are they maintaining it? What's known as an authority to operate is what's provided once an agency goes through this process and accepts risk. It's basically a memo. I think of it as a license to drive. Under the RMF process, you had to do this for every single agency, right? So if you wanted to sell your products or take something from one agency to another, you could leverage your documentation, but you had to be tested every time. FedRAMP fits in here. It is basically the risk management framework for cloud computing, okay? It's built upon the same controls, same processes, same security families, except it's been tailored and customized, right? And in the end, you're still getting an ATO, but with one huge difference. Once a company goes through this process, they don't have to do it again. It's a do once, use many times. Any agency can then leverage it after that. So here at Penguin, one of the key ways in meeting this self-service, we have a self-service on-demand web portal tied into our high-performance computing environment that is basically developed so you can go in, provision, do your own account management, job submission, manage your usage reporting, in addition to core hours, et cetera. Remote desktops with GPU acceleration, the ability to do visualizations in real time over the web through basically any device with a web browser. You now have HPC at your fingertips regardless of the device. With traditional command line interfaces. So everything is still the same. The scheduler commands, the workflow, as though you are still in your local on-prem data center, wherever you are, your lab. It's designed to all be presented the same way. From a resource management perspective, these are kind of screenshots from our skilled cloud clusterware. You can configure and set up alerts. We've got tools available for monitoring, in addition to a wide variety of boot options. But the key thing here is that you can get in and get out and see what's happening on your own, which is one of those key requirements under NIST, is that you be self-serving, you be able to manage and also track all of your usage on your own. So as far as this goes, reporting, statistics, sending things up the chain when it comes to budgeting and saying, hey, here's what we're using right now, this is what we need next month. From a forecasting perspective, you can show by core hour, right, what you're paying for. From a federal perspective, there are some key things here, right? On-demand, managed services, metrics, the ability to come in over the web. Those are all critical factors that are all designed to emulate, that on-prem HPC solution. So from an access control perspective, security in place, multi-factor, deciding who can do what and when, who can run what jobs, things like that. And then, of course, getting rid of that mundane task of onboarding. So to meet expectations here, what we've experienced, the commercial side, we have a commercial pod, and then we have our government pod. Basically identical, except for the Gov pod is designed and built to meet FedRAMP requirements, including critical things like the encryption, like multi-factor support, as well as a lot of the other additional items you see here. So what are agencies asking for, and what have we seen here? They're looking for ready-to-go HPCs, bare metal computing, in addition to capabilities like InfiniBand or OmniPath. HPC support, probably the biggest element that I would say, versus some of the other vendors like Azure or even AWS. Plus, pre-installed applications, licensing is already there, so you don't have to go procure it. And at the end, parallel file systems. So FedRAMP is the path. Thank you.